Della was saying, if you're in Math 1324, you're going to go to that tiny URL link that ends with EPCC TVE2. And if you're in 1314, just remain here in this room and we're going to get started. I'll give everybody maybe about a few seconds just to make the switch if you need to move to another room. In the meantime, everybody, if you want to just put an emoji on how you're feeling today, and then we'll get started right after the emojis.
Thank you, Miss Yvette. And just to let you know, our session today will be recorded. Is everybody ready for spring break? Yes. We are definitely ready for spring break.
Okay, so I think we can get started. And if you have any questions, just feel free to ask them in the chat or open your mic and let us know. So today we're going to be reviewing for your first exam. I mean, sorry, not your first exam, but your second exam, which covers sections 2.1 to 2.6. And during the last few sessions, we've gone over 2.1, 2.2, 3, and 4, and 5. And so I wanted to start this session with examples from 2.6. And then we'll touch on some other examples that we've already looked at before. And so for 2.6, we're looking at graphing what we call a rational function. And a rational function is basically a polynomial divided by another polynomial. So you usually see it as a fraction, okay? And this is exactly what you would see in the WebAssign course. It's a problem. It gives you 4 different steps that you have to do. And so what I'm going to do today is break it up into pieces. So we'll look at A first, then B, then C, and then we'll graph it. Okay, so the first thing is to state the domain of the function for f of x equals 1 over, or 1 divided by x plus 3. And so if you took, when you were looking at section, I think it was like 1.4, it was asking about domain. Okay, so domain is basically all the numbers that you can use and replace x with and still get a solution for y. Okay, so one of the things that I ask my students is, if you see that the question has a fraction, so for example here I can see I have a fraction, then that tells you that there's going to be some numbers that are going to be excluded from the domain. Okay, so anytime you have a fraction, just remember I have a fraction with a variable in the denominator. That means that I have to exclude some numbers. To figure out what those numbers are, you want to take your denominator. So in this case, my denominator is x plus 3. And we're going to set it equal to 0. So here I have x plus 3 is equal to 0. And so if I subtract 3 on both sides, then I get x is equal to negative 3. So what this tells me is that my domain can be anything except for x equals negative 3. And why? If we plug in negative 3 for x over here, then we would end up with something that looks like this. We would have 1 over negative 3 plus 3. And we end up with 0 in the denominator, which we cannot divide by 0. That's why we have to exclude that x equals 0. So in my answers here, it wants us to choose the domain. We would say that it's all real numbers except for x equals negative 3. Okay, so that is the first step, is just figure out what the domain is. And then let's go to the next page. So for step B, it wants us to identify the x-intercept and the y-intercept. So here, in order to find the x-intercept, we're going to set y equal to 0 and solve for x. So here's my function, and I'm going to set y equal to 0. So I get 0 is equal to 1 divided by x plus 3. And then I'm going to multiply by x plus 3 on both sides because I'm trying to isolate x. And when I do this, notice what happens. 0 times x plus 3 is going to be 0. And x plus 3 times 1 over x plus 3 times x plus 3, my x plus 3 and x plus 3 become a 1, or we say that they cancel. And so we end up with 0 is equal to 1. Well, that is a false statement. So what that means is that there's no x-intercept. So in the computer, you would enter D and E for does not exist. Okay, so that is your x-intercept. For the y-intercept, we're going to let x equal 0 and solve for y. So anywhere you see an x, you're going to replace it with a 0. So here's an x, I replace it with a 0. And then we simplify. So 0 plus 3 is 3. So this means that my y-intercept is 0 when x is 0. My y is 1/3. Okay. So all of this information we're going to use at the end. So now it's asking about vertical and horizontal asymptotes. So in section 2.6, this is a big part of that section is to figure out what these asymptotes are. So just a quick overview of what a vertical asymptote is. Basically, it's a line that we graph using a dotted line like I have here. And what it means is that your graph is going to approach that line, but it's never going to cross it or get to it. So to find the vertical asymptote, there's really two steps. The first one is you want to factor your numerator and denominator completely. And once you factor it, you're going to cancel out any like terms that you might see. Okay. And then you're going to set the denominator equal to 0 and solve for the variable. Now, if you cancel any like terms in step number 1, then we're going to have what we call a hole. Okay. So when you graph your graph, it might look something like this. So let's say this is my asymptote, and then I have my graph here. And if I have anything that cancels, my graph might have an open circle. So a hole just means an open circle at that point. Okay. So let's figure out the asymptote for this problem. So step 1, factor both numerator and denominator. Well, 1 is already factored and x plus 3 is already factored. So we can go to step 2. Set denominator equal to 0 and solve for the variable. So I take my denominator, set it equal to 0. So I'm going to subtract 3 on both sides. And I get x equals -3, and that's going to be my vertical asymptote. Okay, so what is this going to look like? At x equals -3, you're going to see this dotted line. If you have a graphing calculator and you're trying to check your work, just remember that your graphing calculator is not going to show you that dotted line. Okay, but it's there. You'll see the graph approaching an imaginary line on in your calculator. What about horizontal asymptotes? So horizontal asymptotes will cross the y-axis at some point, and we still use this dotted line. Okay, there's 3 different situations for a horizontal asymptote. The first situation, if your degree of the numerator is less than the degree of the denominator, then we just say that y equals 0 is going to be your horizontal asymptote, which is the x-axis. The second possibility is when the degree of the numerator is equal to the degree of the denominator. If that happens, to find the horizontal asymptote, we're going to look at the leading coefficient of the numerator divided by the leading coefficient of the denominator. And you'll see an example here in a second. And then the third possibility is if you have a degree, if the degree of your numerator is greater than the degree of the denominator, then we just say that there's no horizontal asymptote. However, if you're at step 3 and you have no horizontal asymptote, you have to check if there's something that we call a slant asymptote. And you're going to have a slant asymptote if the degree of the numerator is one more than the degree of the denominator. Okay, and so I do have an example of that as well. So right now I'm just giving you those two definitions. Okay, so let's look at the example we have here. The degree of the numerator, I have a 1, okay? So the degree of a constant here is 0. And the degree of a denominator, since I have an x, my degree is a 1, okay? So I can say that the degree of the numerator is less than the degree of the denominator. So what does that mean? That means that there exists a horizontal asymptote at y equals 0, okay? And it's the line here that is in blue, okay? So notice that it's the x-axis. We don't normally put this dotted line on the y-axis, so your graph might just look like this, okay? But it is there. We just don't write it since it's already the axis. Any questions on that? Okay, I went ahead and wrote it in blue here. That way you can see that it is there, and then we just take it off. So let's go to the next page. So at the beginning, you had all the questions, right? Find the x-intercepts, the y-intercepts, what's the domain, the vertical asymptote, and so on. And so I just put them here for us so we can see it. That way we don't have to go back, okay? So when you want to sketch a graph that is a rational function, you need to find the x-intercept, the y-intercept. You want to check if there's any vertical asymptotes, horizontal asymptote, or slant asymptote. And then we need additional points. So the first thing you want to do is graph everything that you already know. And so I'm going to graph that. So here is my vertical asymptote in red. And this point here is my y-intercept at 0 and 1/3. And that's all I know, right? So to make this graph might be difficult if that's all the information we had. That's why plotting additional points is important. The points that you want to graph, you want to select points that are on both sides of the vertical asymptote. Okay, so that's important. So I can look at -2, just so I can get an idea of what's going on the right side of the vertical asymptote. And then I'm going to also do 2, because I'm not really sure, right, what's happening with this graph. So the more points I have, then the better. So if I plug in -2 for my x right here, then I'm going to have 1 divided by -2 plus 3. And I get 1 divided by 1 is equal to 1. And if I plug in f of 2, then I get, if I put 2 in here, I get 2 plus 3 is 5. But that might not be enough points for me, so maybe I need to choose a couple of more points. I'm going to try -4, so that's going to be on the left side of the asymptote. And then I'm going to choose -5, which is also on the left side. So we plug in -4, then we get 1 divided by -4 plus 3, and I end up with a -1. And if I choose -5, I get 1 divided by -2, which is -0.5. So I'm going to plot these 4 points. And so you can see them here. Here's the one I got for 2. Here's the one I got for -2, the one I got for -4, and the one I got for -5. Okay, so we can think about what this vertical asymptote means. And that means that your line should get closer and closer, but it's not going to pass. And then this should get closer and closer, but it's not going to cross that asymptote. And so your graph is going to be this graph right here. And the good thing is you can plot more points if you want to. Like if you're still not sure with these 3 points or these 6 points, you can try additional points. Okay, so on WebAssign, they give you these pictures and you're supposed to choose which is your answer. So always check the asymptotes first. So for example, I know that this is not going to be answer because that's not my asymptote at x equals -3. So I can actually cross that choice out, right? And then I also know that this can be an answer because my asymptote is in the wrong side. So I can cross that out. And now it's between this point and this one here. Okay. So we can look at our graph and then make a comparison. And so now notice my graph over here has this graph right here is on this side. So this is going to be the one that matches it. So my answer is going to be this graph here. Okay. So I have a couple of more of these that we can do. I want to stop here and just see if you have any questions on this first example. Okay, so here's another problem coming straight from WebAssign, right? Consider the following function, and then they want us to do all these steps, which are the same ones that I just did right now. So let's look at the domain first. So again, we do have a fraction. So since I have a fraction, that means that I have some numbers I have to exclude. And those numbers are going to be the ones that cause me to have a 0 in my denominator. So just by looking at it, you can figure out what it is, or you can set the denominator equal to 0. So I have x plus 3 is equal to 0. I'm going to subtract 3 on both sides, and I get x equals negative 3. Okay, so my domain is going to be everything except for negative 3. And so here that would be which answer choice? So all real numbers except for x equals negative 3. Okay, so that's for step letter A. And then letter B, get the intercepts again. So to do the intercepts, we let y equal 0. So in other words, c of x, we're going to switch to 0. So I have 0 equals 3x plus 2 divided by x plus 3. To get rid of this fraction, we're going to multiply by x plus 3 on both sides. And so we get 0 times x plus 3 and 3x plus 2 times x plus 3. So on the left side, I end up with 0. 0 times this is 0. And my x plus 3 and x plus 3 will reduce or cancel out, leaving me with 3x plus 2. So I'm going to subtract by 2 on both sides. And I end up with negative 2 equals 3x. So my next step is divide 3 on both sides. So your x-intercept is going to be x equals negative 2/3. Okay, so let's look at the y-intercept. Usually the y-intercept is a little bit easier to work with. We're going to replace all the x's, these x's here, by 0. So c of 0 is equal to 3 times 0 plus 2, and then 0 plus 3. So we're going to simplify, and we get c of 0 is equal to 2/3. So right here, this should say y equals to 2/3. Oops, I lost my pen. Okay. So let me just make that. So again, this should say y equals 2/3. Okay, not x. Okay, so now that we have our x and y intercepts, now we can move on to the asymptotes. So let's go to the next one. So first we need a factor. So let me ask you guys, is the numerator already factored? What do you guys think? So 3x plus 2, is that factored? So there's nothing I can do with 3x plus 2, right? So it's already factored. And then x plus 3, that's already factored. So there's nothing for me to do here. Okay, so, and what I mean, just in, I think I have an example later, but just really quick here. Let's say you had x squared minus 4 divided by x plus 2. Then in this example here, x squared minus 4 can actually be factored as what? X minus 2 and x plus 2. Okay, so now I factored the numerator and denominator, And so at that point, you ask yourself, do you have any common factors? And we do x plus 2. We would get rid of these, okay? And that's going to tell you, since I was able to cancel these, that means that I have a hole in the graph, okay? So let me erase that. But for our example, we're good to go. So set the denominator equal to 0. So here I have x plus 3 equals to 0. Subtract by 3. And x equals -3 is going to be my vertical asymptote. Okay, so it's going to be when you're graphing this, especially if you're like in your actual face-to-face classes or your instructor asks you to turn it in on paper, you want to represent it with this dotted line. Okay, so here for the horizontal asymptote, we have 3x plus 2 and divided by x plus 3. So the degree of the numerator is 1 because the variable for x is 1. And the degree of the denominator is 1 since the exponent for x is 1. So the degree of the numerator is equal to the degree of the denominator. So to get your asymptote, then we take the leading coefficient. In this case, the leading coefficient of the numerator is the number in front of your variable with the highest power, which is x. So we take the 3. And we're going to divide by the leading coefficient of the denominator. And the leading coefficient here is going to be a 1. So my horizontal asymptote would be y equals 3 divided by 1 is equal to 3. And so my y asymptote is at y equals 3. Okay, any questions on that one? And I represented that with the blue line. Okay. So I have all my important information, right? Except for these additional points. So I'm going to go ahead and plot the x-intercept, y-intercept, and the asymptotes. So here's my asymptotes, and then my y-intercept and my x-intercept. So I only have very little to try to make a decision on what my graph should look like. That's why the additional points is important. And so I'm going to use -2. Notice that -2 is here, but it helps me to figure out what's going on with my graph on this side. And I'm going to use +2 just so I can know what's going on this side as well. But more importantly, I need to know what's going on the left side of the vertical asymptote. And so that's why I choose -4 and -5. So if I plug in -2 here, I get 3 times -2 plus 2 gives me -4. And -2 plus 3 is 1, so I'm left with -4. Plug in the 2 here, we get 8 over 5. 3 times -4 is -12, plus 2 is -10. -4 plus 3 is -1. Negative and negative is +10. And then -5 is going to give us 13 halves. Okay, so when I plot these points, then you can see my points are being plotted here. And it gives me a better idea of what the graph should look like. And I know that this graph is going to have to curve and get close and close to the horizontal asymptote and the vertical asymptote. But when I chose 4 and -5, then that gave me this point up here and this point down here. So I can finish the graph on this side. Okay. So again, the additional points is important for us to be able to do our graph. So on WebAssign, again, they give you the 4 graphs. Eliminate the ones that don't make sense, right? Always check your asymptotes first, and that's going to help you eliminate a few of the choices. And so this graph is going to be this one here. Any questions on that? Okay, let's try another one. X squared minus 9 divided by x, same questions, right? We have to find the same stuff. So what is my domain going to be here? Let's see if I'll give you a few minutes or a minute to figure this one out. Here's A, B, C, D, and E. Okay. Yes, so it's going to be E, right? Since we have a fraction, we set the denominator equal to 0. And so 0 would be excluded. And so that's going to be all real numbers except for 0. And yes, you can write it in interval notation. If some problems will ask you to do that, right? So from negative infinity to 0, and then union 0 to infinity. Okay, the x-intercept and y-intercept, we set y equal to 0. And then multiply by x on both sides. Okay, so here's x and x. And my x's will cancel here. So I'm left with 0 equals x squared minus 9. I can factor x squared minus 9. I'm sorry, I can add 9 on both sides. Or you can factor if x minus 3x plus 3 and then set each one equal to 0. Either way would work. And then I'm going to take the square root on both sides. So the square root of 9 is plus or minus 3. So I have two x-intercepts, 3, 0, and negative 3, 0. For the y-intercept, we're going to let x equal 0. So anywhere you see an x, we're going to replace with 0. But now what happened here? What is 0 squared minus 9 divided by 0? So that's not a good thing, right? Because we cannot divide by 0. So it's undefined. So what that means is that the y-intercept we're going to enter does not exist. Okay, because we cannot divide by 0. Okay, so now let's look at the asymptotes. First step, factor. So x squared minus 9 is the same as x minus 3 and x plus 3 divided by x. So can I do this? Because my next step is cancel any like terms. Can I do this here? No, right? I cannot do that because the x minus 3 is together as one whole unit. So I cannot separate that x. If I had x minus 3 here, then I could cancel the whole thing out, but not just the x by itself. Okay, so I cannot cancel anything out. So I set my denominator equal to 0. And so x equals 0 is my vertical asymptote. So before I go to the next slide, go ahead and figure out what your horizontal asymptote is going to be. Because if I click on the slide, you'll see the answer. But what is my horizontal asymptote going to be? And we can break it up in pieces here. What is the degree of the numerator? What's the degree of the numerator? 2. Okay, Rachel says 2, and that's correct. And what's the degree of the denominator? 1. Okay, that's correct. So now, is the degree of the numerator less than the degree of the denominator, or is it greater than or equal to? Top heavy, greater. Okay, so the degree of the numerator is going to be greater than the degree of the denominator. So what that means is that there is no horizontal asymptote. Okay, so no horizontal asymptote. So we could go on with our life, right? But we need to check if there's a slant asymptote. So to check for the slant asymptote, we have to ask ourselves, is the degree of the numerator 1 more than the degree of the denominator? And so that is going to be, I have a 2 and a 1. So is this 1 more than this one? And the answer is yes. So that means that we have a slant asymptote. Okay. So how do we find the slant asymptote? You can use synthetic division, or you can use long division, whatever you feel more comfortable with. So I'm going to go ahead and use synthetic division here. So we have x squared. So I use a 1. I don't have an x, so I use 0. -9, -9. So this is also a review in helping you with synthetic division, right? Because on your test, you might have a synthetic division problem. And then what is my C gonna be? In this case, I have 0. So remember that your C is this number here that we're subtracting. So if I had x minus 4, then I would use 4 and so on, okay? But I don't have anything there, so I'm gonna use 0. So I do have x minus 0, so I'm gonna use 0. So I bring down the 1. So what is 0 times 1? Peter says that in the chat he put that sometimes they ask for the horizontal asymptote, but they do want you to put in the slant asymptote. So if you get it wrong the first time, then make sure you try the slant asymptote. Okay, so I bring the 1 down, and then I multiply 0 times 1. So 0 times 1. And then I put my answer here. So 0 times 1 is 0. And then I add 0 plus 0 is 0. And then I'm going to do 0 times 0 is 0 plus a negative 9 is negative 9. So once you do synthetic division, you want to look at the quotient. So here, since I started with x squared, then I'm going to go 1 degree less. So this one would be 1 degree less, which is just going to be x. You can ignore your remainder. We don't need it right now. And so your slant asymptote is going to be the equation that we get from the quotient. So we're going to have y is equal to x. Okay. So we have our x-intercepts, our y-intercept, our vertical asymptote. We don't have a horizontal asymptote, but we have a slant one. So I'm going to plot that information. So my slant asymptote is this line, the dotted line. And notice it's at y equals x. Then I have my x equals 3, x equals negative 3, and my negative 9. I pick additional points, so I'm using 2, 4, negative 2, and negative 4. So if I plug in 2, I get 2 squared minus 9 is 4 minus 9, which is negative 5, divided by 2. And then 4 is 4 squared minus 9 divided by 4. It gives me 7/4. And negative 2 squared is positive 4. Minus 9 divided by 2 is negative 5/2. And negative 4 squared is positive 16 minus 9 divided by 4 gives me 7/4. So if I plot those points, it's going to look something like this. Okay, so if you need more points, you can pick more points. And so my graph is going to be this line here in blue. It comes close to the asymptote, and then it goes down, and then this one comes up this way. Okay, so on the WebAssign, you have these choices. So again, you can eliminate the ones that you know for sure don't make sense. Like this has the wrong asymptote. And what else has the wrong asymptote? This one. So now you're left with this one here and this one here. Okay. So my answer is going to be this guy here. Yes, you can select any number that you want. Let me see. I can't see the chat anymore. What was your question again? Yes, you can select any point in addition. When you're picking, you just want to pick the points that are on both sides of the asymptote. So that is the important part. Because if you only stick to one side, then you're going to miss out on the second part of the graph. Or you can look at symmetry, right? Symmetry will also help with figuring out if you should have more stuff on the other side. Okay, any questions on the, what is it called? The rational numbers. Okay, so let me go ahead and we're gonna go into some other stuff now. Let me just put in the chat the sign-in form for attendance, and any feedback that you can give us is helpful for us to improve our sessions for you. So the end behavior, here we have our question from WebAssign. And last time I just gave you some graphs that I mentioned. You can always refer back to these 4 examples here. Right now, since you're at home, you can use your notes, right? But let's say when you go back to class and you can't, then you would need to somehow remember all this. And always remembering these 4 graphs helps you to figure out a lot of the things that the questions are asking. So we want to look at the degree, and the degree is odd. So that means we're working with this graph or this graph. And then the leading coefficient is positive. And so this leading coefficient is positive. So that means that our graph is going to behave like this one here. And so on the right side, you can see that it's increasing. And on the left side, you can see that it's decreasing or falling to the left. Okay, so it rises to the right and falls to the left. On WebAssign, they kind of separate it, right? So you want to find the one that says that the graph rises to the right and falls to the left. For the multiplicity, a 0 will touch and turn if its multiplicity repeats itself an even number of times, and it's gonna it's gonna cross whenever it has an odd multiplicity. In a little bit, you'll see an example with that. Then we had the rational zero test, which helps you to find the possible zeros. And to get those, you find the factors of the constant term and the factors of the leading coefficient. Okay, so here we have the factors of the constant is 9. So my factors there are 1, 3, and 9. And my leading coefficient is a 1. So my factors is a 1. So my factors, my possible rational zeros would be -9, -3, -1, 1, 3, and 9. And this is the way that WebAssign wants you to enter your answer. Okay. They put the smallest number to the greatest number. As a list. So if you want to find the actual zeros, then we can use synthetic division. So once you have your list right here, pick one of them and try synthetic division with it. Usually I start with +1 and then I make my way to the other numbers. So here we bring the 1 down. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Plus -9 is -7. And -9 plus -7 is a 2. So that didn't help, right? Because we need to have a 0 there. So x equals 1 is not a 0. Try -1. And so here we can see that we get 0 once we do the synthetic division. And so that's going to make us happy. So now that you have -1 is a 0, we're going to use the quotient. So since your degree was 3, when you start to write your quotient, you're going to have 1 degree less. So for this one, we would have x squared. There's no x, and then we have -9. Then you use your quotient and solve for x. Set it equal to 0 and solve for x. So we're going to add 9 on both sides. Take the square root on both sides. So we get x equals plus or minus 3. So my zeros are -1, since it gave me a 0, +3, and -3. Okay, and then the factors, if we take the -1 to the left side, then we get x plus 1, x plus 3, and x minus 3. Okay, so let's look at this one. List all the zeros, no, the possible zeros, then find the real zeros and the multiplicity, and then determine the maximum number of turning points. So last time I didn't talk about turning points. We'll address it today. So if we look at the possible zeros, let me go back. So here, what is my constant? So my constant is a 0, right? I have nothing there. So the factors of 0 are going to be what? Just 0. Okay, so it's 0. And we're supposed to divide those by the factors of the leading coefficient, which is 1. So if I divide by 1, what is 0 divided by 1? Just 0. Okay, so here my possible zeros are just going to be 0. So I'm going to use this. So I only have one number that I can check. So I'm going to use it to check. So here's my 0. So I have 1 for the x to the 4th, -1 for x cubed, -1 for x cubed, -6 for x squared. I have no x, so I put a 0. And I have no constant, so I put a 0. So I'm going to bring the 1 down. So 0 times 1 is 0, plus a -1, -1. -1 times 0 is 0, plus a -6, -6. Times 0 is 0, 0, 0, 0, 0, and 0. Okay, so I have a 0 here. Is that a good thing or a bad thing? There was a lot of zeros, but that last one is the one that matters. Well, all zeros matter, but this 0 here is important. That tells me that this 0 is a 0. So all that kind of sounded all weird, right? This 0 tells me that this 0 is a 0. Okay, so now I can look at the quotient. So since I had x to the 4th, I'm going to get x cubed minus x squared minus 6x. I have no constant, so I don't have to write plus 0. And then I'm going to repeat the process. Okay, so I'm going to take my coefficient of 1, -1, -6, and 0. And if I do the possible rational zeros again, I only have 0. So I'll put 0 here. Bring down the 1. 0 times 1 is 0. Plus -1 is -1 times 0 is 0. Plus -6 is -6 times 0 is 0. Then I have a 0. So I got 0 again. So Ruben's really happy about that. So that's awesome, right? So now I can move on, use my quotient again. Okay. So my quotient, since I had a cube, now I go 1 less. So it's going to be x squared minus x minus 6. So notice now we have a quadratic equation, and that is wonderful because now we can solve that equation using what? Somebody type in one method you can use. So Ruben said a factor. Okay, what's another way? Factor, okay. What? Quadratic formula, okay. So I'm going to use the quadratic formula. And I just let it all come out at the same time, but here's my quadratic formula. So for b, I have a -1. And then I have -1 squared minus 4. A is 1, and c is -6. Okay. So negative is +1. -1 squared is 1. -4 times -6 is +24 divided by 2. And then 1, we get plus or minus 25 divided by 2. We get 1 plus or minus square root of 25 is 5. So we have two answers, 1 plus 5 divided by 2 or 1 minus 5 divided by 2. So my answers come out to 3 and -2. So you could factor this as well, which would have been quicker, right? So we have our zeros. So the possible zeros were 0. And then my actual real zeros were -2 and 3 that we got from the quadratic formula. And then 0 that we got from doing this synthetic division. Okay, we need the multiplicity. So my 0, my degree is 4. I should have 4 zeros. So I'm going to list them 1, 2, 3, 4. So 0 appears twice. So we say that it has multiplicity of 2, which the number 2 is even. So the graph is going to touch and turn at that point. For -2, it only appears once. So the multiplicity is odd. So that means the graph is going to cross. And at x equals 3, the graph is going to cross. Okay, the maximum number of turning points can be found by taking the degree minus 1. So n here represents degree. So the degree minus 1 is going to give you your turning points. So here we have 4 minus 1 is equal to 3 turning points. So 3 turning points does not mean that you should see 3 actual turning points. You just cannot have more than 3. You could have less than 3. Okay. So after we did all of this, we're going to plot our points, -2, 0, and 3. So here's -2, 0, and 3. And then we're going to do our end behavior. Okay, so notice here I have an even exponent, and this is positive. So that means that your graph is going to rise to the right, and it's going to rise to the left. And then notice here at x equals 2, I made my line go through it, right? Because it's going to cross. So that's why I went all the way down here. And at x equals 3, I also made it cross. Now I need to figure out what's going to happen in here. Okay. So in order to figure that out, we need to plot in our own points, right? Extra points. And so remember, to make a good guess, you want to plot points between these zeros here. So what I use on the next page is -1, +1, and +2. So I want to know what happens here, here, and here. Do you have to do all 3? No. You could do 2, or can you do more? You can do more. If I get -1 for x to the 4th, and then -1 for the cube, and -1 for the square, so I get -1 to the 4th is 1. -1 cube is negative, times a negative will be a positive, and then -1 squared is +1 times a negative gives me -6. So f of -1 comes out to -4. So here's my -1, and here's my 4. Okay, so now we go to x equals 1, plug it in, we get -6. So at x equals 1, I'm going to get -6 right here. And then for 2, 2 to the 4th, 16. 2 cubed is 8 times the negative, -8. And 2 times 2 is 4, times -6 is -24. So I'm at -16. And I kind of like squeezed it in here, but -2 gives me -16. I'm sorry, +2 gives me -16. And so now I can see what's going on with my graph, right? So at this point, what is the graph supposed to do? Is it supposed to cross, or is it supposed to touch and turn? Touch and turn, okay? And so maybe you're asking yourself, at -1, should I, at this point, do I keep going down, or can I start turning? If you want to be like super accurate, you can maybe plot a 0.5, and then if 0.5 is higher, then you know that the graph it turns here as well. So 0.5 can tell you if you need to go lower or if you need to go up. Okay, so here we go. So this is what my graph would look. The graph comes here, it touches, and then it turns, and it comes down. So I'm going to show you my graph and then the computer graph. Okay, so you can get an idea. Okay, so this is probably going to be the last example. Here they give you this function, okay, and they give you a 0, and they want you to find the rest of the zeros. But notice that my 0 is imaginary, okay? It's okay, you can still use synthetic division. So I'm going to have 4 plus 2i. I have a 1, -12, 52, and -80. So I bring down the 1, and then I'm going to multiply 4 plus 2i times 1. So I get 4 plus 2i. -12 plus 4 is -8, and then I still have my 2i. Okay, so now I need to multiply 4 times this, and 4 times this. And then I need to multiply 2i times this and 2i times this. Okay, so I'm going to multiply this out. And I get 4 times negative 8, negative 32. 4 times 2i is 8i. Negative 2 times 2i times negative 8, negative 16i, and so on. Let's simplify in here. 8i minus 16i is 8i. And this I squared is a negative 1 times a 4. Gives me a negative 4. I'm going to add negative 32 and negative 4. Negative 36 minus 8i. So 52 plus negative 36. 52 plus negative 36. 16 minus 8i. And then we start again, right? We start multiplying again. So all of this times this. And this times this. Okay, so if I do that, then I have 4 times 16, 64. 4 times negative 8i is negative 32i. 2i times 16 is plus positive 32i. 2i times negative 8i is negative 16i squared. 32i and negative 32i is 0. So I'm left with 64 minus 16i squared. Take this I squared, make it a negative 1. Negative 1 times negative 16. Positive 16 plus 64. 0. Okay. If you don't get 0 here, that means you did something wrong because they told me that it was a 0. So my quotient, I started with x cubed. So now I'm going to have x squared. This is going to be my coefficient for x. And this is my constant here. Okay. So it looks weird, but not to worry. We do the same thing. The coefficient for x squared is 1. Coefficient for this is negative 8 plus 2i. And then we have 16 minus 8i. Bring down the 1. Negative 8 plus 4 is negative 4. Notice that my imaginary numbers become 0. 4 minus 2i times negative 4 is negative 16 plus 8i. That becomes 0. So my quotient, since I started with x squared, now it's going to be x. So I get x minus 4. And I set that equal to 0. So x equals 4. So my zeros are going to be the 4 that I have here. This should be x equals 4. And then 4 plus 2i and 4 minus i. So this should be a 4. Okay, so that's going to be our zeros. Now we have about how many 5 minutes? So let me see what I have left here. So this was from last week. It's the exact same example, and so I'm going to send you this. I'll send you the PowerPoint. I know I've been emailing them to you like on Monday or Tuesday. But once I'm done today, I'll make sure I send you, well, once the video has been posted, so maybe tomorrow morning, I can send the video and this PowerPoint in case you need to see this again. But we have about 5 minutes, so if there's any questions, then we can take those right now. And then we also have our tutors who are here waiting in case you have any questions. And then please don't forget to sign in and write any feedback that you might have. Okay. And then, of course, you all, I don't know if you have my email, but I know I posted it last time. So make sure that you, I typed it in wrong. If you were here last week, I sent you an email with additional links for some videos that I made for my class. And so that videos was on 2.6. And so I do have a YouTube channel. You can click on one of those links and it'll give you all my other videos. I have videos for every section that, let me give you the link. I have videos for every section of the book. So I'll just give you one. And then I have videos for like how to use the calculator, how to use the graphing tool, and so on. Okay, so there's different videos that will help you how to use the WebAssign and so on. So I'm going to put just an example of one of the videos. And then when you get to that page, you can see all the other videos. Okay, is there any questions that anybody might have right now about anything from chapter 2? Is everybody ready to take their exam? I know some exam due on Sunday. Some of you have it maybe due during spring break. Maybe some of you have it due after spring break, but whenever your test is, some of you have it today, okay? So good luck to you guys, and if you need any help, just send me an email. I will answer those as well.
Thank you, Ms. Chuka. And I would like to invite everybody to attend the upcoming TVE sessions that we have after spring break. We'll be covering on March 26th, exponential and logarithmic equations, and also system of equations for both courses 1314 and 1324. We hope you have a wonderful spring break week, and know that online tutoring is here for you guys. It's free. Take advantage of it. We're open from 7 in the morning until midnight. And actually, if you have any questions, we do have tutors available who will stay right now to work with you. And if you'd like to come in a little bit later to our online tutoring room, we will have tutors available until midnight. After that, we will be closing for spring break, but not this weekend, but the following weekend. The tutors will be available starting on Saturday and Sunday, March 20th and 21st, regular hours, to prepare you and help you with any upcoming assignments that will be due once we return from spring break. So thank you so much, Ms. Chuka, for presenting today. Thank you, Mr. Carizales. And thank you to the audience for coming and being such a wonderful audience participating. So please feel free to stay behind. You have lots of links in the chat. Very helpful links, and stick around if you have any questions. You guys have a wonderful spring break too. And please don't forget to fill out the survey. It's a very short survey to receive credit for attending. And they're posted in the chat. Thank you, Ms. Chuka. Thank you, Peter. And I'll be stopping the recording. Ah, there's the flyer. Thank you. The upcoming flyer. This is for, you have Wednesdays from 1 to 1:50, academic success. You got this. We're here to help series. On Fridays at 1 o'clock to 2, we have career and degrees. And on Fridays from 3 to 4, of course, you know, we have our Happy Math Hour workshops for Math 1314 and 1324 with separate links into both rooms. So you can see down below at the flyer, March 26th when we return, we'll be covering the exponential and log equations for 1314 and 1324. Again, system of equations. Excellent. You guys were a great audience. Thank you so much for participating.
If anyone wants to work with a tutor, just let us know, and you can send a private message or you can put it in chat, and we will put you in another room with the tutor.